the engine that can reach Mars in 30 days. No fuel? In the world of space exploration, reaching Mars has always been a long and fuel-heavy journey, typically taking 6 to 9 months. But what if we could cut that down to just 30 days, and without traditional rocket fuel? A revolutionary propulsion concept known as the Pulsed Plasma Engine or Direct Fusion Drive, DFD, may soon turn this science fiction idea into reality. Developed by researchers at institutions like Princeton Satellite Systems and supported by NASA, this engine uses nuclear fusion, the same process that powers the sun, to create thrust in a highly efficient, clean, and continuous manner. Unlike chemical rockets, which burn fuel and push off in powerful but short bursts, fusion engines offer sustained acceleration over long periods. That means a spacecraft could slowly build speed and reach incredible velocities, shortening the trip to Mars drastically. What makes the idea even more exciting is that this type of engine doesn't rely on conventional fuel tanks filled with tons of liquid hydrogen or kerosene. Instead, it uses small amounts of helium-3 and deuterium, lightweight isotopes that, when fused together under high temperature and pressure, release immense energy. This energy heats plasma, which is then ejected at high speed through magnetic nozzles, generating propulsion. Since the mass of fuel needed is far less than traditional rockets, it frees up space for scientific equipment, supplies, or even more passengers. Also, this propulsion method reduces radiation exposure for astronauts because the journey time is shorter, lowering health risks significantly. Another theoretical engine making headlines is the MDrive, which claims to work without any propellant at all. Though highly controversial and not yet proven under rigorous scientific scrutiny, it works on a principle that seems to violate Newton's third law, creating thrust by bouncing microwaves inside a closed chamber. If it can be validated, it could revolutionize not just space travel but energy and transportation systems across the planet. However, until then, fusion propulsion remains the most promising near-future technology. What does this mean for our Mars ambitions? With a 30-day trip, a crewed Mars mission becomes far more realistic. Shorter travel means less risk, fewer supplies needed, and a higher chance of success. It would allow for quicker missions, emergency return options, and more frequent launches. It also opens the door for cargo runs, pre-settlement missions, and possibly tourism in the distant future. NASA's Artemis program, aiming to build a sustainable lunar base, could serve as a stepping stone for launching deep space missions using such advanced engines. Of course, challenges remain. Fusion reactors are complex and require extremely high temperatures to operate, over 100 million degrees Celsius. Containment, stability, and miniaturization are huge engineering hurdles. But breakthroughs in superconducting magnets, plasma control, and compact reactor design are bringing this vision closer to reality. Private companies like SpaceX, along with international agencies, are closely watching these developments, potentially paving the way for collaborative missions powered by fusion engines. The idea of traveling to Mars in 30 days without traditional fuel is no longer just a dream. It represents the future of clean, fast, and efficient space travel. As our understanding of plasma physics, fusion, and propulsion systems grows, we edge closer to transforming how humanity moves through the solar system. This could be the beginning of a new era, not just of reaching Mars, but colonizing it and beyond. A fuel-free future for space travel might just be around the corner, where the stars are no longer out of reach, but just a month away. Like and subscribe.